Okay, guys, in this lesson, we're going to learn how to identify the slope of a line. Slope is simply how steep a line is. We're going to be able to identify a slope from a graph as well as from two ordered pairs or a function table. Here are the four states of slope. Remember, when reading a graph, you read left to right. So this first graph, as we go left to right, our skier is going uphill. So this means this has a positive slope. Our second graph right here, the skier is going downhill. This is a negative slope. The third skier is neither going up nor down, so we say this has a slope of 0. The last slope is kind of silly. A skier cannot ski vertically up a hill, so we call this slope undefined. Slope is a ratio of rise over run. We use the variable m to represent the word slope. It is the vertical change compared to the horizontal change. And remember, work from left to right when finding the measure of the slope. So we're going to find one point and then work our way toward the right. So here in our first example, I'm going to use this point here, 2, 6, and I'm going to see how steep this line is, what is the movement from this point, 2, 6, to the ordered pair 4, 7. So remember, slope is rise. So we're going to go up 1 and then to the right 2. So my slope would be 1 over 2. Or I could choose this point, 4, 7, and see the steepness to the point 8, 9. So this 2, my rise is up 1, 2, and my run is 1, 2, 3, 4. I have a slope of up 2 and right 4, which simplifies to the 1/2. You can choose any 2 points on a line to find the slope. But again, remember, work from left to right and always identify the rise, the vertical change first, because it goes on top in our ratio. Let's determine the slope of this line. Notice that this is going downhill, so we will have a negative slope. So I'm just going to choose this point here, -6, 7, and I'm going to work my way toward this point. Again, do not do the run first, do the rise. And in this case, my rise is negative. I'm going down 2 units into the right, 1, 2, 3. So my slope is -2 over 3. And we're always going to the right, so our bottom ratio number is always going to be positive. If we have a negative slope, I'm always going to attach the negative to the vertical change, to the top part of my ratio. So I'm going to go down 2, right, 1, 2, 3, down 2, right, 1, 2, 3, down 1, 2, to the right, 1, 2, 3. It is a constant down 2, right, 3, down 2, right, 3, down 2, right, 3. This is what we call slope for linear functions, a constant rate of change. It changes at a constant rate. That is what creates a line. Also, let's always keep our slope as a fraction and always simplify if needed. Let's not convert it to a mixed number or a decimal, because slope is 2 values that gets us from point to point, the rise compared to the run. Let's identify this slope. So I'm going to, it says first, let's identify 2 points on the graph. So I can identify this point. This is -3, 0, and this point is 0, 2. So first I'm going to identify the slope graphically, and then we will use this formula to find the slope algebraically. So I'm going up 1, 2, and to the right 1, 2, 3. So I have a slope of 2 over 3. Now here's the formula, because you're not always going to have a graph. So here is y2 minus y1. So let's label all of the parts of our ordered pairs. This is my first x value, y1. This is my first y value. This is my second x value because it's my second ordered pair, and my second y value. So it's the change of the y's compared to the change of the x's, the vertical change compared to the horizontal. So here we go. Y2 minus y1 of 0, x2 minus x1. Be really careful with your negatives because our formula uses subtractions. So this is 2, and then I'd say keep, change over 3. So we can see that graphically we got 2/3 as well as algebraically. So make sure you write this formula in your notes. You will be using it throughout this unit. Let's identify the slope graphically. So my 2 points, I'm just going to choose this point. This is 0, 5. And the next one is 1, 3. Guys, remember, you can choose any of these points that you want. So we're going to go down 1, 2, and to the right 1. So we have -2/1, or we could just say -2. If we were graphing, we would need the 1 to know that we're going to the right one. So this is down to right 1, down to right 1, down to right 1, and so forth. Now, let's practice this algebraically and just prove that it is -2. So the formula says y2, 3, minus y1, 5, over 1 minus 0. I get -2/1. This slope, I'm going to identify, let's just identify these points here. So this one is -6, -6. And I can use -4, -5. So I'm going to go up 1 and to the right 2. Up 1, right 2. Up 1, right 2, and on and on. My slope is 1/2. So I'm going to plug this into my formula. Slope m, -5 minus -6, -4 minus -6. Keep, change. This gives me a +1 over a +2. We have 1/2. Here we have a slope, so let's identify 2 points. This is our horizontal line. The equation is y = 4. So I can just pick a couple of points here. So we have 0, 4 and 1, 4. So let's do it algebraically first. We have y2, 4 minus y1 of 4, and then 1 minus 0. So we get 0/1. You can have a 0 in the numerator, just not the denominator. So this has a slope of 0. There is no vertical change. It is just a constant going toward the right. So our slope is 0. So when you see the horizontal line, y equals some number, whatever it goes through on the y-axis, note that this has a slope of 0. Don't say it doesn't have slope, it does. It's a value of 0. Now let's choose 2 points on the vertical line, and we know this is not a function. It doesn't pass the vertical line test. So here we have -4, 0 and -4, 1. When I put this into my formula, I have 1 minus 0 over -4 minus -4. And we get 1/0. You cannot have a 0 in the denominator. That is called undefined. So my slope here, you write the word undefined. This is the equation x equals -4. The vertical line has a slope that we call undefined. Now let's take 2 points from a function table. You can choose any 2 points. I'm just going to take the top two. I like to write them out. -3, comma -9, and point -1, comma -6. So this time we don't have the graph, but we know our formula now. So we have y2 minus y1 over x2 minus x1. This gives us 3 over 2. So up, it's going to go up 3 and right 2 on our graph. Again, you can choose any 2 points and you will simplify to get 3 over 2 every time. Again, I'm just going to use the top 2 points. Put it into the formula, y2 minus y1 over x2 minus x1. That gives me -1 over 3. And I could see that as my x values increased, my y values were decreasing. So I can see that I did have a negative slope. So this would be down 1 and right 3. -7, comma 8, and -3, comma 6. 6 minus 8 over -3 minus -7. I have -2 over 4, and we always simplify. So this is going down 1 and right 2. And again, as my x's increase, the y's decrease, giving me that negative slope. -1, comma 12, -3, comma 7. Slope is the change of the y's over the change of the x's. When you have a negative over a negative, it becomes a positive. So this is actually going up 5 and to the right 2. -7, comma 3. Notice our y's are all the same number. This is a function. Our slope is going to show we have the change of the y's, which is going to give us a 0 over the change of the x's. So it gives us 0 over 4. So we have a slope of 0. So this was the vertical line going through where y was 3. -1, comma 8, -1, comma 6. We notice our x's are repeating. They have different outputs, so we know this is not a function. And we know that the only line that is not a function is the vertical line itself, but let's prove it. 6 minus 8 over -1 minus -1. We get -2 over 0, and we can't have a 0 in the denominator, so we say it's undefined. This would be, if this is our coordinate plane, and here's -1, this would be the vertical line, x equals -1. Now let's just say we have these 2 points instead of a whole table, so we have to use these 2 points to find the slope. 8 minus 2 over -7 minus -4. This gives us 6 over -3, which is -2 over 1, or -2. But for graphing purposes, I would need to know the run. So this is going down 2 and right 1. Here we're going to have 9 minus 5 compared to 4 minus 8. The change of the y's over the change of the x's. We get 4 over -4, so that gives us -1 over 1, or just -1. So this is down 1 and right 1. -5 minus -2 over 4 minus -2. Oh, I put that in the wrong place. I'm glad I caught that. So erase that. It's -5 minus -3 there. So -5 minus -3, the change of the y's compared to the change of the x's. This gives me -2 over 6, which is -1 over 3. So it's down 1 and right 3. We have 2 minus 0 compared to 0 minus -6. Again, be very careful with your negatives. So we have 2 over 6, which is 1 over 3. So it's up 1 and to the right 3. -1 minus 7 compared to 4 minus -4. I get -8 over 8. That gives me -1 over 1 or -1. Down 1, right 1. We have -1 minus 7 over -4 minus -4. I notice my x's are repeating. This is not a function, so this must be the vertical line with an undefined slope, and it is. So I'm going to say undefined. Can't have a 0 in the denominator. This would be the vertical line. Now we have repeating y's, which is fine. So we have 7 minus 7 over 1 minus 9. We know this is going to have a 0 slope because it is the horizontal line. Now let's compare slopes. So we're just going to find the slope and see which is greater. Now, if it's negative or positive, that doesn't matter. That's just the direction of the line. So here, I'm going to have -8, 8 and -7, 6. So slope is 6 minus 8 over -7 minus -8. I get -2 over 1. So my slope is -2. In this example, -8, 12 and -6, 8. My slope is 8 minus 12 over -6 minus -8. I get -4 over 2, and my slope is -2. So function 1 slope is equal to the slope of function 2. Again, let's just find the slope using any 2 points. So I get a slope of 3 over 2. Eight minus 12, -6 minus -8. I get -4 over 2. So here my slope is -2. So this is 1.5. This is -2. And again, we're not looking at the negative part because that just tells me the direction. So the slope, function 1, is not as steep as function 2. My slope for function 1 here, I'm going to get 3 over 2. Six minus 8 over -7 minus -8. And function 1 has a less steep slope as function 2. I hope this helps.